Mechanics is an ancient subject. However, nowadays, with the aid of computers, the capability of mechanics is maximized to meet the needs of our modern technology. Think about problems like, how does a car resist vibration when driving on rough roads? How to optimize the design of a professional drone? What is the performance of a cell phone in a job test? How to accurately release spine stress during an operation? All these problems are highly related to mechanics. In general, mechanics is the study of how things work or even how the world works. It is applied in many different technology fields which affect the modern industry and our everyday life. To name a few, automobile, electronics, oil industry, biology, packaging, or even sports helmets and shoes. This MOOC is the first step of a series of courses for engineering simulation. It aims to provide necessary background of physics for every engineer to understand and use simulation in mechanics. Before conducting simulation for complex mechanical problems by computational solver, it's essential for you to master the physics behind them. For example, how deformation is described. What's the internal force in materials under deformation? Why there are different materials models and how to choose from them, or even how the problems can be solved numerically. All such background knowledge is the keystone of mechanical simulation. It can be heavily related to mathematics. In this course, instead of throwing out theories and mathematical formulations, we will use images, animations, and examples related to daily life and modern industry to explain the concept. This way, the underlying physics is better understood. To start with, let's define the scope of our course. We're going to learn about the macroscopic behavior of a structure or material. We will be looking for the motion, deformation, stress, and strain of a structure as a holistic body. On the other side, if we zoom in into the microstructure of any material, the molecular structure is exposed. The study of such microstructure is called molecular or quantum mechanics, which falls out of the focus of this course. What is discussed in this course will be continuum mechanics. As implied by the name, we treat the material as continuous mass instead of discrete atoms. As for continuum bodies, there are two main types of them. One is fluid, which can be liquids and gases. Fluids cannot resist deformation force. It moves or flows under the action of the force. Another type of body is solid. Solids can resist deformation force while at rest. And this course is all about solid mechanics. In mechanics, we can treat a solid body as a rigid body, or we can treat it as a flexible body. For rigid bodies, they do not deform under the action of applied force. The study of rigid bodies look for the movement of the system and reaction forces from the movement. For example, here, the parts of the engine connection rod are treated as rigid bodies. Or these gears are treated as rigid bodies to find the needed turning force for this rigid mechanism. On the other side, when a body is treated as a flexible body, we look for material deformation of the body under external loads. For example, the deformation of a car after a strong impact, or the gear teeth deformation caused by contact between different gears. For most of this course, we treat bodies as flexible bodies and look for deformation of them. With the scope of this course defined, now let's get started.